at the start. Okay, now about the insulation model. QuickField allow us to do easy calculation that's very common. So we are back to our insulation model. Okay. So what I've done here is just to put an impulse of 100 volts on the conductor directly. I have a 0 volt as reference here. It is put on around the model. I mean, in fact, it corresponds to the metal part of the body. And it's quite easy to calculate the leakage current. We have just to select a contour here. So it's a contour, it's an insulation that go around the winding and have directly the current here and the reactive current too. So we can also calculate it along the time, but I think we don't have a lot of time right now. Can try, but maybe we can start our last poll, Vladimir. If you are ready.
Sure.
The question poll is, do you use exported field for your design?
We have 75% of our audience voted already, so let's wait a few more seconds. I'm calling the poll.
Yes.
And let's see results. So, opinion is divided. So some people use, some people no, which is reasonable. Okay, let's continue.
Okay. Now we can see here as a result of our overvoltage of 100 volts. So along the body, I mean the total leakage currents will have a peak of 0.4 milliampere for the reactive currents, and a negative one of minus 0. milliampere. So with QuickField, you can easily design the insulation of this kind of appliances. The last thing I wanted to show to you is an example of tolerance analysis. For this, I use a simple model. Just here we are talking about the plunger. I mean, if we have a subcontractor and want to ask him to manufacture a plunger, you have to give tolerances. So what we can do easily with this software, this piece of software, is this. I've defined here the end of the plunger, and the body that is here is a corresponding shape. In fact, it just corresponds to this kind of design by this firm. It's by Electronics. You can see that inside the design of the plunger is a little more complex because the stop here have a conical form. The conical form is an aspect of the simulation you can do, but as you can do anything, it's okay. You can see the influence of the shape at the end of the plunger here. So if we have a shape, we have angle tolerances to give to the supplier or to the subcontractor. So it is what I've done here with QuickField. These points have been defined is A, E, C, and B here. So I want to get the value of the mechanical force of the plunger to get the position of the point A and B, which are defined by X and Y. The variation is randomly around the position of these points. I mean, it's 0.1 millimeter. And what is surprising in the result, I mean, if you see the plot here, you can see that simply changing the tolerance of 0.1 millimeter will change the value of the maximal force at about 10%, because we have here a nominal of 10 Newton, and here we have a standard deviation of 1 Newton. But the plot can be seen differently here also. We can see the result according to the position of the point, and it can be very useful for the designer, but also for the person in production. Okay. So I've nearly finished with this webinar. Just remember that if you are interested, it's possible to comment other detail of the plunger. I mean, the mounting model here. The use of temperature or response time in datasheet to design a plunger. Sweeping with label mover, we can do many things with it. Sweeping with TCL script, I mean, to have advanced analysis with TCL and QuickField, and the use of computer algebra systems such as MATLAB. The dynamic behavior of the plunger can be presented in another webinar. This one is very important for complete system. So here I think I finished with the presentation of the use of QuickField in electromagnetic plunger appliances.